Sir, very good morning.
Good morning, TRG and Co.
We start another 2 minutes exact time.
Fine, sir, fine.
Okay.
So, happy
Thank you.
Teachers' Day.
Happy Teachers Day.
Thank
And
you, sir. Thank you, sir. Thank you.
thank you.
Thank you, sir. Happy Teachers' Day, sir.
Thank you, Ma. Thank you.
Morning, sir. This is Aisha Millet. Happy
Yeah,
Teachers' Day, sir.
good morning. Wishing the same to you.
Thank you, sir.
Nice. Okay.
Thank you, sir. Happy Teachers' Day.
Thank you. Happy Teachers' Day.
Okay, sir. We start our session, our time.
Fine. Nice, sir.
Okay. I introduce you. My dear participants, this day,
Yes, sir. Yes, sir.
yes, this day is A blessed day to you.
Thank you, sir. Same to you. Good morning.
Happy Teachers' Day to all participants, all teachers, all students.
Yeah.
So today you are blessed in the sense respected Professor Dr. M. Selvam, Vice Chancellor of Bharatidasan University, is addressing in this FDP. So he is a teacher to all teachers. And this is the right day to him to meet the right participants. So the teacher is a teacher, teaches always throughout his life. So Dr. M. Selvam is teaching throughout his life to students more than 33 decades. He is the Vice Chancellor of Bharatidasan University. It is a great credit to participants, great credit to organizers. Other most important feature I would like to share to the participants, please you be with his session. Please be with his session 10 o'clock to 1 o'clock. Because he will share his rich experience in teaching, learning and research and extension. And he is the quality ambassador. So quality dimension in research, he is the expert in India. And he is the NAC ambassador. From our scheme, he is the ambassador. And great writer, great thinker, great visionary for enhancing the higher education here. All the participants, please take note of the entire session. This session will serve as a treasure to you to enhance your academic performance, research performance, and overall achievements in your life. This session will help you for your life, not only for teaching. Not only for teaching. So, the methodology, the presentation methodology you will learn. You see the PowerPoints, all the PowerPoints. You see the slides. You can learn the methodology to prepare the slide methodology for presentation. All presentations, these slides will be new. We won't use yesterday's slides for today's presentation. You won't use today's slides for tomorrow's presentation. So every time the presentation will be fresh for the welfare of the student. So today he is addressing, that is ICSSR sponsored capacity building program. Definitely your academic capacity, research capacity will increase in this session. So there, today is the day. It is his day. So I extend greetings to Professor, and it is a birthday to M. Selvam.
Thank you, sir. Thank you.
So it is a teacher's day. Happy birthday to Professor Selvam on behalf of the participants. So you remove, all the participants, please you think of the teacher's day is his birthday. On the same day he is addressing to the students. It is a great credit to the students, great credit to the participants. And I thank the ICSSR, because ICSSR has sanctioned this program for the welfare and for academic enhancement and research enhancements of the participants. So this is a great session. He was the professor here for more than 30 years, and you might have seen his writings, you might have seen his deliberation, you might have seen academic acumen and leadership acumen and administrative acumen. A great scholar, and he's a great student. So now you listen, now you get this deliberation. It will be a great blessing, and it will be a great treasure, and it will be a great prize and blessings to you. As in Tamil literature we speak, Paal Ninainduttum Tayinum Sala Parindu, he will take care of the students, take care of the participants. So I am pleased to welcome, pleased to invite Professor Selvam to deliver special lecture in the two session multivariate analysis. Student, you can freely interact and whatever your issues or clarification related to your research problem or further or postdoctoral research or any research projects, if you interact with professor, their interaction will be much helpful to you. It is a very great time, a great opportunity, great prize to you, time to you. Today's Teachers' Day. Sir, on behalf of the university, participants and department and organizer, we welcome you, sir. And
Thank you.
now this is time to you give your expert lecture to the participant. The participants are ready. They are highly encouraging. They are receptive. Participants are throughout India. Many students are here. They will interact. You provide time to them. They will interact with you after your session. Thank you very much, sir. Thank you. We are
Thank
so
you.
happy to listen your lecture. Thank you very much.
Thank you, Dr. Gurumurthy, my great colleague, friend, and all. I am happy to be part of this 10-day ICSSR program on capacity building for research scholars and teachers. I remember, Dr. Gurumurthy, in 2013, we had a similar program.
Yes, similar offline program.
Yeah, 2013,
Yeah.
sponsored by ICSSR, you know very well. So this is our second program, perhaps, for the university, Hierarchical University, from the ICSSR for the Department of Commerce. So nice. So welcome all of you. At the outset, I place on record my congratulations to the organizers because they have to write, they have to follow, they have to get people, resources, and stage the program in a neat manner. And all that is being done by Dr. Gurumurthy and his team, ably assisted by Dr. Vinayakamurthy and others. Good wishes to all the learners. Everyone is a learner. I am a learner. I appreciate a program of this type because at least for this program, I would have prepared at least 60 hours for your information exclusively for this program. So that means it makes me to further probe into the nuances of multivariate analysis. So that is an opportunity I keep learning. Further, I have to tell you, this day is also another day of importance for us. That is the birth anniversary of one of the greatest freedom fighters of India, late Sri Vavu Pillai, Vavu Chidambaram Pillai, also known as in Tamil the Sekkilutha Semmal. And also the Remembrance Day of Saint Mother Teresa. So it is therefore a great day. To be part of this day is also great. So I'm happy to be part of this function. And before I proceed, a couple of slides on the Teachers' Day, that is Dr. S Radhakrishnan, the former President of India, a teacher, a philosopher, a Vice Chancellor of 2 universities, ambassador to USSR, earlier UNESCO, statesman of excellence, Vice President, President, and Bharat Ratna. So a teacher should have a vision to rise to the level of getting Bharat Ratna. That's a message I get from Sri Dr. S Radhakrishnan's life. So such a great personality. So we are fortunate to have this program coinciding with this great day and talk a few words about that great personality. His first book, The Ethics of Vedanta and Its Material Presupposition, is a MA thesis, MA degree dissertation published in 1908, Madras University. He says philosophy is a way of understanding life. You are all either doing Master of Philosophy or Doctor of Philosophy. So please understand, philosophy is the way of understanding life. That means, in your context, understanding the whole picture of the research that you are doing. Totality. As I used to put, the highest form of that, the deepest part in that, the broadest aspect, and also the most finest things. Ongi ஆழ்ந்து அகன்ற நுண்ணியனே. So that's a full understanding means you must understand things to the height of height, to the depth of depth, to the breadth of breadth, and to the minutest aspect of the minutest aspect. So that is philosophy, that is research, that should be our research. His study of Indian philosophy served as a cultural therapy. So every research work should become a therapy for problems of the society. As his study on Indian philosophy served as a cultural therapy of the whole world. I have to take you to Russia, USSR, where Dr. Radhakrishnan served as the ambassador. A couple of days before his departure to India after the term comes to an end, he called on Joseph Stalin, the premier of the nation, USSR. Dr. Radhakrishnan patted on his cheek and also back. Joseph Stalin said, "You are the first person to treat me as a human being, not as a monster. You are leaving us and I am sad. I want you to live long. I have not long to live." So what words he is telling. So such a great personality, Dr. Radhakrishnan. And their relationship, which has flourished over the years and has become even now stronger. So what I'm trying to sell from am I audible now?
Yes, sir, it's audible, sir.
Oh, I go back and tell you. Welcome all of you. This is a great day. This is not only Teachers' Day, but also the birth anniversary of one of the greatest freedom fighters, late V.O. Chidambaram Pillai of Thoothukudi. It's also Remembrance Day of Saint Mother Teresa. So such a beautiful day. Before I proceed further, I would like to speak on a couple of words about Dr. Radhakrishnan, former president of the country, is a teacher, philosopher, vice chancellor, ambassador, statesman, vice president, president, and Bharat Ratna. So every teacher should emulate Dr. Radhakrishnan ji, because as a simple teacher, he blossomed into a philosopher of repute throughout the length and breadth of the world, and later served the country the highest post, the president of the great nation, and also Bharat Ratna. So teachers of today must emulate Dr. Radhakrishnan. Dr. Radhakrishnan is known for his contribution to philosophy, Indian philosophy, Western philosophy in Indian setting, Indian philosophy in Western setting. So all these are his great works. And he says that philosophy is a way of understanding life. Yes, the philosophy that he was talking about relates to that. What about you are all, we are all philosophers in a sense, master of philosophy, doctor of philosophy. So see the importance of the word philosophy. That means understanding life in that context, understanding your research in all great depth. That is very, very important. You must know the highest of the highest points of your subject, the deepest and the deepest point of your subject that you have proved, the broadest and broadest point of the subject that you are exploring, and also the minutest, finest detail. That is what is required. So as research scholars, as faculty members, we have to keep this point in our mind and do that. So that is the kind of thing. As a research scholar, we have to learn from the life of Dr. Radhakrishnan ji. And a couple of another thing that I would like to say is on 5th of April 1952, a few days before Radhakrishnan's departure to India, after his tenure as ambassador of the country comes to an end, he called on Stalin and told, he patted him on his cheek and on his back as well, so friendly. And Joseph Stalin said, "You are the first person to treat me as a human being and not as a monster. You are leaving us and I am sad. I want you to live long. I want you to live long. I have not long to live." So these are his words.
Hello?
A relationship which has flourished all over the years has become even stronger. What I'm telling here, the strong foundation of the relationship between the two countries, USSR and India, which Dr. Radhakrishnan built, even today stands as test of time, and it has become even more stronger. So that's a kind of what I'm trying to tell. Every researcher, as the day passes on, must become stronger in his or her understanding of the subject, as the relationship also gets stronger as we build relations. Some of the quotes that Radhakrishnan would say, when we think we know, we cease to learn. Very, very important thing, very important thing. Just because we have got a paper published or PhD completed, thesis completed, a conference paper presented, it doesn't mean that we know everything. If we think like that, we cease to learn. The worst sinner has a future, even as the greatest saint had a past. No one is so good or bad as he imagines. So what the saintly words of Dr. Radhakrishnan says, everyone has a future in this world. Then, a couple of other things. This is Teacher's Day. Alexander the Great says, "I am indebted to my father for living, but to my teacher for living well." Aristotle says, "The one exclusive sign of thorough knowledge is the power of teaching." That means when you take the job of or profession of teaching, we must have thorough knowledge, as Aristotle had underlined. So we are all research scholars, including myself. We have to keep on doing research. Okay. So what is research? Research is to see what everybody else has seen and to think what nobody else has thought. This is research. This should be the way research must be seen. So we have to see what everybody else has said on the topic wrote on the topic that is an extensive, deeper, up to latest review of literature. That is what research is, to see what everybody else has seen. With the stock of all that, you have to think, we have to think as researchers in a way that nobody else has thought. So that's the kind of research required for us. How can we get such kind of research? That research is possible when we have imagination. Einstein says, imagination is the highest form of research. Imagination is the highest form of research. We have to imagine. To imagine, we cannot imagine in vacuum. The more exposure we have, the more imagination comes. The more we dwell into a problem, more opportunities for solving, more ways of solving the problem comes before our eyes. Therefore, imagination is required. That's what is required. And it takes less time to do things right than to explain why you did it wrong. Please note that all research scholars must ensure that your research is pure, is fabulous, fantastic, right, correct. And your publications are also that class, that caliber, so that you need not explain what kind of wrong that you had done, because you had not done any wrong. But if you have done any wrong, to explain that, the why aspect of that, no answers starts with one single why. Next why, next why, next why, another why may be required. Therefore, do things the right way in the first attempt itself after careful execution. With this prelude, I am getting into data analysis. Research scholars of late are flooded with data. So much of data, enormous amount of data. Okay, data collection is a difficult thing, and it has to be done very, very scientifically. And in this context, the research tools that you are using for data collection must be excellently designed. Otherwise, the data you have got may have numbers or may have facts, but may not be having meaning. Therefore, you have to put in many hours of your intelligence so that the questionnaire, the schedule, and all that you design must be of the greatest kind of thing in terms of quality. So when that is ensured, the data part is fine. Now the data analysis. What is analysis? Analysis is noun. Analyze is verb. To analyze means to dissect, to cut it, to examine. Why do you cut? To examine that. Why do you examine? To find whether any new revelation is available from that. So to analyze means to dissect, to examine. The purpose of examination is to discern certain unknown features that is now you have found while others haven't earlier. Therefore, data analysis refers to the examination or dissection of data and drawing data-based fact, data-based truth. Why is a dissertation done by students of archaeology, botany, commerce, women's studies? Why this dissection is made? To know the inner dimensions, the features, the factors, etc. of the dissected part or parts. Why should researchers do dissection of data? To have a deeper understanding of the inner dimensions and features of issues studied through analyzed and dissected data. So the point is a deeper understanding of the inner dimensions and features of the issues that you have studied. This is what is required. If you dissect data to such an extent and you have a deeper understanding of that, and what this deeper understanding will lead to, this may lead to something like putting an equation as Einstein had put decades ago, E equal to mc square. So E equal to mc square. So after dissecting so much of data analysis only, the new revelation, the new fact that Einstein could establish. So that should be the kind of this thing. And what are the types of data analysis? Univariate analysis, bivariate analysis, multivariate analysis. This is one kind. Descriptive, inferential, prescriptive, qualitative, quantitative, hybrid, parametric, non-parametric, and much more things are there. And of course, we are going to concentrate on multivariate analysis. Please note, any researcher must be comfortable with the univariate analysis, bivariate analysis, then only we can think of multivariate analysis. So the univariate analysis that we might have done our 6th standard, 8th standard, 10th standard, first year become or somewhere else as mean, median, mode, etc. Univariate. Bivariate, correlation, regression, such kind of things, association of attributes, bivariate, multivariate, the next level. Okay. Now we have used the word variate. What is that variate? Is it the same as variable? So what is a variable? Is it same as variate? We have to be comfortable with that. A variable is a possibility, is a chance. It is a may kind of thing. May means may happen, may not happen. So it's a may kind of thing. What about a variate? A variate is a reality, is a fact. It is not may, it is type of this thing. Put in words, a random variable or stochastic variable is a variable whose value is subject to variations due to chance. Wikipedia explains like this. It is a possibility. Take the case of a dice, a 6-sided dice. At any roll, either you may get 1 on the top or 2 or 3, something like that. But we cannot definitely say which you will get. Therefore, 1 to 6, any of the things can happen. So this is a variable. Similarly, for a coin toss, either the head or tail might come up. Therefore, that is the kind of thing. Whereas, when you roll a dice and you get 6, that is variate. What you actually get is variate. What you could get, variable. Next time you roll the dice, you may get 3. You got 3, and that 3 is variate. So this is how we have to understand the difference between variable and variate. Now, multivariate analysis. Multivariate analysis refers to a group of statistical procedures that simultaneously analyze. Please note that simultaneously analyze multiple measurements on each individual or object being studied. Definition given by McDaniel and Roger Gates. Take this world. The world is so complex world, whether it is business world, it's a family life, or running education institutions or business institution, or even any kind of social activity that you or somebody else might be engaging, everything is complicated today. Everything involves multiple variables. So when there is no single thing that is influenced by just one factor or just another factor. A multitude of factors are behind every single happening. Sometimes many happenings also take place, not a single happening. So multivariate analysis is the order of the day. Multivariate analysis is the order of the day. So your univariate and bivariate statistics, just to understand basic concepts of statistics and the relationship between variables. And for any research work, I don't think that such univariate and bivariate analysis would be sufficient. You have to think of multivariate analysis. Thanks to or kudos to the information communication technology, machine learning, artificial intelligence, data mining, and statistical packages. All these are helping us in doing the multivariate analysis. They are helping us enormously. A kind of classification of multivariate methods is attempted here. The totality of multivariate analytical methods, to know the totality, you have to ask a question. To know anything, we have to ask a question. What is the question? Here you have to ask, do some of the variables depend on others? See, in multivariate analysis, half a dozen, 1 dozen, 20 different variables you handle. The question is whether some of the variables of the 6 or dozen or 20 or do depend on others. If your answer is yes, you have to go for dependence methods of multivariate analysis. If the answer is no, that is, none of the variable is having any relation with other variable. Therefore, no relationship. In that case, independence method of multivariate analysis is to be done. Okay. Multivariate analytical methods, the analysis of dependence, analysis of interdependence, where one or more variables or dependent variables to be explained or predicted by others. The others mean the independent variables. So dependence, there are dependent variable, independent variable. So you can do that. Interdependence means something, there is a mutual relationship. Not one is exclusively depending on that. The other is also depending on the first one. The second is also depending on the first one, that kind of thing. In such cases, you are going for cluster analysis or factor analysis, such kind of thing. Then the dependence methods, furthermore classification we think of. How many dependent variables and what kind? One dependent variable only. And that one dependent variable may be a ratio variable or interval variable, nominal variable or ordinal variable. This is a very, very basic thing, but basic things are not learned by many. So when you deal with data, we must be able to tell whether it is nominal data, ordinal data, interval data, or ratio data. So these are all, accordingly we have nominal scales, ordinal scales, interval scales, and ratio scales. Okay. There is only one dependent variable, and that dependent variable is ratio type or interval type. In that case, multiple regression you can take. The data, nominal data or ordinal data, multiple discriminant analysis they can do. how many dependent variables and what kind. One dependent variable we took and the kinds we saw, and also we have seen what methods we have to adopt. When there are many dependent variables, maybe ratio or interval, nominal or ordinal, in such case, in the case of ratio or interval type, many dependent variables you encounter, then multivariate variance analysis you have to do. You know variance analysis. This is multivariate variance analysis. If the information, the data are nominal or ordinal, and there are many information types, then you go for conjoint analysis. What about any number of variables, any type? Then you can perhaps go for canonical analysis. Next, multivariate analysis classification, we continue. Independence methods. The question, are the data metric? Now I take a break. Are the data metric? Should we use is the data or are the data? Whether or is okay or is I have to put. I know you know that it must be or, because data, the word data, plural, is plural. So when you use the data as a subject, as a noun, we have to use plural verb. So we cannot say is the data. It is or the data. Now the question, are the data metric? What is metric? Metric data means either it is interval or ratio oriented. What is an interval data? What is a ratio data? That is a huge exercise. I thought I can avoid. Anyway, you read it. But one point I will tell here. Ratio scale has an unique origin and it is uniformly graduated. Ratio scale has an unique origin. For example, take the meter scale or a foot scale. The measuring scale I'm talking about. It has a unique point 0 and uniform progressions, centimeter by centimeter up to 100 centimeters, therefore 1 meter, or inch by inch up to 12 inch, therefore you get 1 foot long a scale. So that is ratio scale. Ratio scales are considered to be the elitist kind of scale because these are amenable to any kind of measurement, any kind of statistical treatment. The other one is the interval scale. What is this interval scale? Take the case of thermometer. We have Celsius thermometer, we have Fahrenheit thermometer. In the Celsius thermometer, there is a point called as 0 degrees Celsius. But 0 degrees Celsius is not equal to 0 degree Fahrenheit. Actually, 0 degrees Celsius is equal to 32 degree Fahrenheit. Therefore, what is 0 in one scale is not 0 in the another scale. Whereas in a meter scale or a foot scale, 0 meter is equal to 0 foot. 0 foot is equal to 0 centimeter. Everything is 0. But whereas 0 degrees Celsius is not equal to 0 degree Fahrenheit, therefore, these scales have all the other features. Uniform gradations are there. But unique origin is not there. Therefore, they are called interval scale. Okay. So when the data or interval or ratio, it's fine. These are metric. Factor analysis you can use, cluster analysis you can do, metric multidimensional scaling also you can do. Whereas if the data are non-metric, that means nominal or rank. I have to also tell a couple of minutes I will take and tell you what is a nominal scale. Nominal scale is a kind of classification only. Just classification. Take the case of cricket players or any football players for that matter. At the back of their, even the chest as well as at the back, a number they will display. What is that number? This number has nothing except telling he is so and so, that's all. If somebody wears that somebody is going to be known as that number. Therefore, it is just a classification kind of thing. So instead of telling now 42 and 32, it can even put -1, -10. No, because -1, -10 has no meaning here, except -1 is given to somebody, -10 is given to somebody. So therefore, there is no unique origin, there is no uniform gradations and all that. Whereas the rank scale, when there are 100 things, 100 students who have scored great marks each, and you are ranking the students from bottom to top or top to bottom, so you have ranks. But the point is, the first rank holder might have scored 98.9%. 98.9%. The second rank holder, 98.8%. The difference between the two is just 0.1. Whereas the third rank holder, he might have scored only 98. So the difference between second rank and third rank is 0.08. Between the first and second, it is 0.1. Between second and third, it is 0.8. Therefore, there is no uniform gradation. There is no unique origin. So that is the rank data. So this much small understanding will help. Maybe some might have some thought over what is nominal, what is rank. Some doubt you might have been harboring in your mind. That doubt I have clarified right now. So when the data are nominal or rank or kind of thing, non-metric multi-dimensional scaling adopted. So this is how it goes. Again, the analysis of the variables. See the techniques. Dependent variable, independent variables, the technique that you can go for. Single dependent variable, metric one, then single non-metric, single metric, multiple metric. So such classifications are all possible. Okay. So when the dependent variable is single and metric and independent variable multiple and metric, multiple regression. Dependent variable is single and non-metric, independent variable multiple and metric, logistic regression. Logistic regression. Dependent variable single and metric, independent variable single or multiple non-metric, ANOVA you can use. Thus it goes. Okay. Another one, in business, what kind of multivariate analysis we can do? This is what. So a promotional mix you can decide, pricing a product, forecasting your sales, incentive compensation, and goal setting for different departments or individuals. So like that, for several applications, a lot of multivariate analysis businesses are using. And now you have huge list of multivariate analysis tools: multiple regression, logistic regression, partial least square regression analysis, multiple correlation, canonical correlation, perceptual analysis, discriminant analysis, multivariate analysis of variance, MANOVA, CHI, that is chi-squared automatic interaction detector, factor analysis, principal component analysis, cluster analysis, metric multidimensional scaling, non-metric multidimensional scaling, correspondence analysis, conjoint analysis, structural equation model. Like that it goes. Not that every model is exclusive. In doing an analysis, other tools will also get involved. When you do a multiple regression analysis, automatically you'll be getting the correlation related data also you'll be getting. Okay. Now I am taking to multiple regression analysis. Multiple regression analysis. So maybe 3 or 4 kinds of things only we can see. See, the whole of multivariate analysis requires an exclusive 10-day program. Then only we can master to an extent all the multivariate analysis with all gadgets available with us. What I am going to tell you here, we may not be solving any problem because all such solving is possible only with the help of computers, with the help of statistical packages. So what we are going to do here, when a multiple regression analysis result is available, how we can interpret that? Then, when we can go for multiple regression, what conditions we have to ensure? So that kind of points only we can discuss in this kind of work. Okay. So multiple regression analysis, we know regression. Regression basically a bivariate analysis when there are two variables only, A and B or X and Y. Whereas when you have more than two variables, we think of going for multiple regression. So MRA, multiple regression analysis, studies the relationship between a single dependent variable and several independent variables, DV, dependent variable, IVS, small s, independent variables. From known independent variables, prediction of the unknown dependent variable is done. Yes, ultimately this is what we are doing, predicting the dependent variable given the independent variables, and with the independent variables we work out an equation which will help us in predicting the dependent variable. For example, impact of rainfall, temperature and amount of fertilizer on crop growth. Impact of online classes. Right now we are having online classes. Impact of online classes, on-campus classes and self-learning exercises on students' performance. What are the assumptions here? No heteroscedasticity. In other words, there must be homoscedasticity. In other words, constant variance. The size of the error in our prediction doesn't change significantly across the values of the independent variable. You know, you are making a prediction of X and Y. Okay, an equation is there. You have predicted, but actual value is will be different from what is predicted. Therefore, you find the difference between actual and the predicted one. The difference is the error. That error may be having no relationship with the among themselves. The error terms shouldn't have any relationship among themselves. If the error variables are having a kind of pattern, either continuously increasing or continuously decreasing, or having a periodical jumps and troughs, ups and downs, then the error terms are having some kind of statistical pattern, either increasing or decreasing or a circular movements. In that case, there is no homoscedasticity, rather there is heteroscedasticity. One of the assumptions of multiple regression analysis is there is homoscedasticity. That means the error terms do not have any pattern among themselves. So that is one of the very important assumptions. The next assumption is no multicollinearity. What is this multicollinearity? You know, you have one dependent variable, you have many independent variables. If the independent variables among themselves are interdependent and they have high correlation among themselves, that is a situation called as multicollinearity. So multicollinearity is a situation where the independent variables have among themselves high degree of correlation. When such is the case, we have to think of pruning your data set. Pruning means reducing your data set, whether some of the independent variables can be ignored. We have to think of, because their inclusion doesn't add to any precision in your prediction. In that case, why should you have that? So that's the question. So therefore, multicollinearity. Then independence of observations. Of course, you all know that everything must be random observation. Therefore, the previous observation should not have any impact on the next observation. I can put you an example. For example, when a coin is tossed, the previous, it happened to be head. The next time, it may turn head or it may turn tail, whatever it is. Because it is not having any, the coin is not having any memory to come with, last time we turned head. Now, let me turn tail. Such kind of thinking the coin is not having. So therefore, the toss of coins is always independent kind of thing. That means the previous happening has no influence over the subsequent happening. Similarly, in data collection also, it must be there. For example, if you give your questionnaire to a group of students, if what one student is doing, another student is just taking that, then there is a lot of dependence here. One person is just taking what the other person has done. That should not happen. Okay. So there must be independence of observation. That is, one person is depending on other to fill the data. There is dependence. It should not happen. Linear relationship. This is very important. In all the multiple regression analysis, multivariate analysis, this linear relationship is always stressed. That means y equal to b naught plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4, it goes. It is not taking any power function. Okay? Linear relationship. No square, no cubical kind of thing. We experiment here. Okay? Nice. Then normal distribution of values. So this is another assumption. We all know that. So we assume that the data are normally distributed. So then the sample size must be 10 to 20 times the dependent variable entities. 10 to 20 times. Some people say 15 times. So a range is given. So with this only we can think of doing a good multiple regression. Okay. So multiple regression, the independent variables x1, x2, etc., xn on one side. The black box is doing some process. This is what your software package is doing. The black box, the process, it does it, immediately gives the answer. For example, even with the Excel kind of thing, you want to do a correlation, okay? Write the row from cell A1 to A10. You have data for variable X. What you will be writing? So in the window, you will be writing A1 colon A10. Then another series, in the B column, we have put all these things. So B1 to B10. The moment you do, instantly the correlation value or the regression value comes, whatever you asked for. What was happening inside, we do not know. But as a student, you would have worked out in our first UG or PG, wherever. So therefore, what you are doing on your notebook is done by the system within itself. It's not visible to us. So therefore, we call it as a black box. and the result is y, that is the output. Okay, so this is how it happens. And when we go for multiple regression, we have to think of regression equations. Y equal to a plus bx plus e for error. I told you earlier an error variable. Okay, this is what? This is univariate. I mean, only one dependent variable. One dependent variable, one independent variable. The second one, y is the dependent variable. All the x's are x1, x2, x3. These are all independent variables. So in the second equation, y equal to a plus b1 x1 plus b2 x2 plus ei. Here, the x1, x2 are independent variables. There is also an error term. Error term is only one term. Then multiple regression we are going. So more than two independent variables we think of. So y equal to, instead of a, I am introducing b naught, b0. So that all the coefficients will be in b. There is no need to have an a kind of thing. Therefore, this way, in the earlier equation can also be done like that. Okay. So therefore, b naught plus b1 x1 plus b2 x2 plus b3 x3 plus, it goes up to n number of x variables you may have taken. Therefore, bn xn, and ultimately again it comes the ei. Okay. Then when you do this multivariate analysis, and for a particular level of x1, particular level of x2, x3, etc., xn, you would have got all the values b0, b1, b2, b3, etc., bn, where solution book gives. Put all these values, you will be getting a particular predicted value for the dependent variable y. So this is a predicted value. Therefore, it is written as y subscript e. E means expected. Here this e is expected value, predicted value. So when you put on y e, that is expected value, there is no question of any error being there. There is no error. Only the difference between y and ye we call as actual y and predicted y. The difference is called the error term ei. So when the equation is written as y equal to etc., the last term is to be ei. When your equation is ye is equal to expected y is equal to b0, b1, x1, etc., at the end you don't have one ei. Error term is not there. So this is what we must do. Certain fundamental things we have to know about that. And let us come to some a real kind of thing, real world kind of thing. This is a capital account model. This is a method of predicting the exchange rate value of one currency in terms of another currency, taking into account certain independent variables. Okay. This is called capital account model. There is another model called as a current account model. So these models are named like that. S equal to, S means spot rate. The words S stands for spot rate, spot exchange rate. Okay. Of rupee in terms of dollar, you can take. Or dollar in terms of rupee, you can take. For $1, how many rupees it goes today? That's a spot rate of dollar in Indian rupee. How is that determined? How is that influenced by? People have worked like this and they give this. So that spot rate, exchange rate of one currency in terms of another currency. Here exchange rate of a foreign currency in terms of domestic currency. Exchange rate of foreign currency in terms of domestic currency. This is what we call as a direct quote. In a direct quote, you are in India, we are in India, we need not buy rupee. Rupee is available. If at all we need, we have to buy dollar if you want to go to certain foreign countries. So what you are going to buy? Dollar. So therefore, what you are buying? Dollar. So per dollar, how much rupee, how many rupees you have to give? That is the usual way of asking the question. So per dollar, how much? Therefore, this is direct. With 1 rupee, how much dollar I can get if somebody asks? That becomes indirect quote. That becomes indirect quote. So the S is a direct quote of, say, dollar in terms of rupee. That's why it is put. The equation, the regression equation is like this. Please note that the previous slide, we have put ye is equal to b0 plus b1 x1 plus b2 x2 plus. The same thing I'm using here. Instead of b0, I'm using one k. Instead of b1, I am using what is called as alpha. Instead of b1, I am using an alpha. And the x1 is not one single kind of thing. Rather, here in this context, it is mh minus mf. That is money supply in home country, that is India, minus money supply in the foreign country, here US dollar, so ESA. So what is the money supply in India minus what is the money supply in USA? Any country which has issued more amount of money supply, so India has issued more money compared to America, then what this factor will become? This MH minus the MF will be a positive value because MH is more than the MF. Therefore, it will be more. And this is more, what it will become? This will increase the value of the dependent variable, the S. We started with S. S equal to K plus alpha into MH minus MF. Minus beta into, instead of beta, I could have used B2 earlier, the previous slide, B2, followed by one X2. Here it is beta, instead of X2, it is YH minus YF. YH minus YF. YH means the GDP of home country, gross domestic product of home country, minus GDP of the income of the other country, the foreign country. So Y is used here. Y is this minus sign. Before beta, a minus sign is put. This is put because if a home currency output is more, home country output is more than the foreign country output, then the home country will have more value. The home country will have more value. So to more value means, if rupee is having more value means, what does that mean? From 74, if it comes to 64, rupee has more value, it means. From 64, if it goes to 74 per dollar, rupee is losing its value. Therefore, the negative sign is important here. That's how it put. Plus theta into IH minus IF. This is a home currency interest rate minus foreign currency interest rate. If Indian interest rate is more than American interest rate, rupee will depreciate, rupee will lose its value. Lose its value means we have to pay more rupee to get the same dollar. Therefore, the S, right hand side, left hand side edge will be more. Therefore, the positive aspect. Lambda int plus lambda into pi h minus pi f. That pi symbol refers to inflation in home currency area minus inflation in foreign currency area. So why I have taken a kind of a complicated example. See, when you want to learn things, we have to go step by step. But how long we can go step by step? We have to also encounter with slightly difficult kind of thing. Okay, then only our mind will get prepared for facing a greater kind of thing instead of smaller kind of things, bigger kind of things, more complex things than less complex ones. So therefore, what I have presented so far, it is available in the rest of the description in the slide. Now, another example I am going. See, here is a situation. You want to get wide area network around your home or around your institution, and for that you have to make a payment to the telecom service provider. So how much you will be willing to pay? So several telecom players are there. Everyone is able to sell, and everyone is having a price, a different price from each other. So people must be willing to pay for, and how much you are willing to pay for? Here, the amount that you are willing to pay for is taken as the dependent variable. It depends on so many other things. What are the so many other things? See the description below. X1, X2, X3, X4, X5. What is X1? Range of coverage. Range of coverage is one of the variables, independent variable. So if the service provided, okay, this is a whole of Tamil Nadu, great. Is whole of South India, still great. Coverage is more, willing to pay more. Okay. Mobility from one area to another. Is that easily done? Or there is no problem, just like that. It gets auto connected. So mobility of coverage. Then the sound quality. So whether the sound is free of noises. Noises are unwanted. Sound is wanted. So the sound must be free of any noises. Therefore, sound quality is required. How important this is for anyone. Accordingly, he or she will be willing to pay more. Then connectivity importance. Yes, I am there, I could not connect. People say it is Tamil Nadu, but when I steer my car outside Trichy for 10 kilometers this way or that way, I am not getting connectivity. So connectivity becomes an important factor. So this is an independent variable, and this influences the amount that you or I or anybody willing to pay. Then affordability, another thing is affordability. So everyone wants to have all these things, good things. The range must be more, mobility must be very easy, sound quality must be the best, and connectivity again the best. But you must be able to pay. Therefore, affordability is also there. So all these 5 variables are taken here, and these variables here, an interval scale is adopted here. An interval scale is adopted. See, this is the last word, rating. That means the respondents are asked to check what will be rating for the importance of coverage factor for the WAN connectivity offered by one particular service provider, telecom service provider. And you may rate from 1 to 9 or 1 to 7, 1, 2, 3, 4, 5, 6, 7. 7 means maximum importance you are giving. 1 means the least importance you are giving. So therefore, here the data are interval data. Please note, interval data. Sir, you may ask, what about, I could have taken the range, any telecom service will tell some, in terms of numbers, what is the range? Sound quality also, anything in this world can be measured and expressed in number. Therefore, they may have a kind of measurement for everything. But what is the importance of each of these things for you, that is for the respondent, is the factor we are considering here. Therefore, the scale is put into rating. Another this thing, if the variables are, each one is in different units of measurement, it may not be correct to interpret the results. So therefore, some kind of uniformity is injected here to this way. So anyway, either the ratio must be ratio scale, either the measure should be ratio, that is actual metrics of range, actual metrics for mobility, or actual metrics for sound quality, or actual metrics for connectivity, or the interval scaled one, the importance rating 1 to 9, 1 to 11, 1 to 7, odd number kind of thing, we take it. So this way, the data would be easier to collect and analyze. Okay. Now we have collected the data from so many people. So how many we have dealt with 5. I am in the previous table now. X1, X2, X3, X4, X5. Suppose we are going for 11 grades and for each. 11 grades for each. Therefore, X1 11 grades, X2 11 grades, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ratings. So there are 5 into 11, 55 ratings. So when there are 55 data points, how much should be your sample size? Earlier, the previous slides, we have put 10 to 20 times of data points. Here for a single person, the data points work out to 50 from 55. 55 alternatives you can choose. Okay. Therefore, 55 into 10, 550 respondents. Then only your study will give the great result. Okay. So that's the point you have to keep in mind. And you have decided upon the number of sample, this sampling method. In the sampling method, many people write the simple random sampling I have adapted. I must tell you all, simple random sampling is not at all simple. It's not simple. It's not simple. It is really complicated one. So simple random sampling is not at all simple. So it has a design. It must ensure that every unit in the population, you have to define the population first of all. And every unit in the population, that is individuals or companies or whatever it is, must have equal opportunity of getting included or not. Therefore, how you can ensure that? You can go for a systematic random sampling or lottery method of random sampling. That is, when there are 1,000 people, out of the 1,000 people, we have to pick some 550. Each one must be given a number, separate sheet, put it, and randomly pick one after another, 550. This is the random sampling. Is this the random sampling people are taking really and writing so? I have my doubts. So random sampling is like that. If it is systematic random sampling, you know that out of 1,000 you need 550. So therefore, you have to decide, or let this be made like this. Out of 1,100, instead of 1,000, I am writing it. Out of 1,100, you have to pick up 550. Therefore, every alternative person you can take. So that way also you can do. But in this case, every alternative kind of thing, there is a kind of pattern in it. Therefore, this is not this cannot be a great random sampling. In that case, what you have to do? You have to go for 5,500 people. Out of that, from that, you are going to pick up some 550. That means from the first 10, you pick up 1%. Say you are picking up the 6th person, then systematic random sampling goes 6%, 16th person, 26%, 36%, like that it goes. So therefore, so random sampling, when you are writing random sampling, please ensure that it is really random. Okay, simple random sampling is not that simple at all. It involves a lot of computations, lot of procedure. Okay, you have done it and you are getting a result like this. Multiple regression equation, y equal to a, I can even write b naught. Okay, instead of a, it can be b naught. Next slide, I have gone. Okay, b1. Right. Go up. Go up. Ah, yes, this one. Yeah. So a plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus b5 x5, like that. Okay. The first a could be, I could have written as b naught, b 0, subscript 0. Please note that 1 1, 2 2, 3 3, 4 4, 5 5, these are all subscripts. Whereas if you take it to the top of each letter, not this side, top, that becomes superscript. That becomes superscript. Here this example is solved and you are getting a solution like this. Y equal to this thing. 0.82 plus 0.44 x1 plus 0.69 x2 plus 0.21 x3. So this is what the computer gives as a result. For 550 people, out of 5,500 population, at the rate of 1:10, you have taken 550 people. All the questionnaires are given to them, and they have given their ratings, importance rating for each of the 5 variables over 1 to 11 points grades. And out of that, a scale is, the computer gives a result like this. This is your equation. Y equal to a plus b1 x1 in terms of values, y equal to 0.82, that is the constant or y-intercept. We call this as y-axis intercept, you know that. b1 x1, 0.44 x1. Okay, so can we interpret this one? We can interpret. For example, if the variable x1, the variable x1 is increased by 1 unit, the value of y will increase by 0.44 unit. Similarly, if the variable x2 is increased by 1 unit, the dependent variable y will increase by 0.69 units, keeping all other things constant. The rest of x1, x3, x4, x5 must remain constant. Okay, suppose you reduce the value of x2, variable x2 by 1 unit, keeping other things the same. What will happen to y? Y's value will decline by 0.69 points. This is what. Here, we can do hypothesis testing. H0 means null hypothesis. BI means B1, B2, B3, B4, B5, here up to 5. All these things are all equal. That means the 0.44, 0.69, etc. No, here we have positive values for all these things. Whereas the statistics may say, yeah, you have it, but these are not statistically significant one. Therefore, the statistical package may say that These are all simply equal to 0. It may tell. So therefore, that is the null hypothesis. Alternate hypothesis, BI is not equal to 0. So the values 0.44, 0.69, 0.21, 0.45, these are all positive values not equal to 0. And that if the test says so, we accept. Without testing, we have it like that only. Therefore, testing is needed to make a conclusion. And based on this, a multiple regression table is available. Please note that we are not going to solve any multiple regression problem. We cannot solve with our pen and pencil. So we have to do it with a package only. Either there are many software packages available, statistical SPSS, you all know that. Then we have Minitab and Statistica and several things available. So your institution also may have one of these things bought. You can apply, and that requires some kind of learning. Then only we can do. Now in this table, the results of the research scholars must be capable of interpreting the results, because the system will give the result, the package, SPSS package will give the result, but we have to ensure that you must, with all your data, with the nature of the data, etc., what statistical, what multiple regression, what multiple analytical, this thing you have to do, that you have to decide. And you have gone for multiple regression analysis and you are getting a result like this. Now we can interpret this one. So the B1, B2, B3, B4, these are all beta coefficients already presented. The first one can be written as even B, intercept can be written as B0. Nowadays people prefer to write as B0 because everyone will be B series only, B0, B1, B2, B3. Earlier, it is a one-way, one, that is one dependent variable, one independent variable. Then this O equal to A plus BX, that was useful. But whereas when we go for this kind of multivariate analysis, we can, even for intercept, it's better we go for B0. Therefore, B0, B1, B2, B3, the values are available. The standard error of these values are given. The standard error of these values are given. And these things will automatically come in the working. Then another column, the next column, it also gives the t value, the t statistics. The t statistics it gives. Test statistics it gives. Okay. How is this obtained? The value of B column values divided by the corresponding standard error gives the t statistics value. T statistics value. Got it? So this is the one. So that means 0.82 divided by 1.67, you get 0.49. So this is how it goes. 0.44 divided by 0.10 is equal to 4.25, it is written, but actually it should be 4.4. But why this difference is, the difference is there, we have reduced the decimal points, therefore the correction error had been there, therefore it should be mathematically, for this table, it should be 4.4 only. Okay, so like that it goes for each and everything. Now the t value, is that significant or not? The last column, the p value is given. So wherever the p value is less than 0.05, we say this is significant. That means the b values are significantly different from the assumed zero value. Significantly different from the assumed zero value. What is the actual value? That you have to see from there. Okay. In one case, for sound, it is 0.10. This means this is equivalent to 10%. If you have taken your level of significance as 10%, if your level of significance, if taken as 10%, perhaps the sound also becomes a significant variable. If you have taken 1% as a significance level, that is alpha level, or 5% as your significance level, that is alpha level, the 0.10 that is equivalent to 10% is more than 0.01 or 0.05. Therefore, this is not significant one. Okay, so we accept in this case the null hypothesis true. Okay, so this is how this interpretation goes. You have to do like that. Then the multiple correlation. So this is connected with your multiple regression. When you are doing any multiple regression analysis, multiple correlation results also used to come side by side. Therefore, the result is available. The multiple correlation, that is all the variables on one, all the independent variables on one side, the dependent variable the other side. So the multiple correlation is done, and this is equal to 0.8567 correlation. When the correlation is squared, it becomes R square, which is equal to 0.7495. Please note, any number less than 1, if you square any fractional number less than 1, you square, the square will be smaller one. So the 75, this square is called, R square is called the percentage of variation in the dependent variable explained or influenced or predicted by the independent variables. So here with the R square of 0.7495, roughly 75%, 75% of variation in the dependent variable. What is the dependent variable? How much amount people are willing to pay for the wide area network service. Okay, that is influenced by the influence that the influence of the 5 variables: connectivity, affordability, and all that 5. All the 5 could explain 75% of the variation in the dependent variable, that is how much people are willing to pay for. Then you may ask, what about this 25%? Yeah, the remaining, the 20% may be influenced by other factors which we have not brought into analysis. So if perhaps if this is a good level of correlation as well as coefficient of determination R square 0.7495 or 70% is a good one. If it is just say 0.18, that is 18%. In that case, all over this thing is wrong. The variables that you have chosen, the independent variables are not capable of predicting the dependent variable. Therefore, we have to do the work again, because for a research scholar you may not do, but as a company it has to do, because a company wants to take a decision based on research. It says that only 18% is influenced by the chosen factors. That means all these factors, the chosen factors, are irrelevant, it seems. Therefore, the company must redo the whole exercise. So from the business perspective, it is different. For a researcher's perspective, you may say all the factors are less important in predicting the dependent variable. There you may end it, but a business person cannot end it like that. He has to further proceed. So this is how it goes. Another exercise is there. Shall I continue, or you have some break?
Sir, if you need any break, give me, please, sir.
You have a break. Okay.
For 10 minutes, you can take break, sir.
Okay. Okay. Nice.
Thank you, sir.
Okay. Fine.
Thank you, sir.
Nice, sir. Okay.
Thank you, sir.
Excuse me, sir. One clarification I would like to ask you, sir.
Please. Okay.
With regard to the equation which you have found, y is equal to beta a plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 up to beta 5 x5. Now, why didn't you add an error term in that equation? This is my question. So definitely an error term needs to be added because the coefficient of determination of that particular equation is 75%. That means there is invariably there is an error term included. So why didn't you omit? Is it by mistake or any other? See, I'm asking, is there any rule regarding any particular theoretical base for that? Normally, when we are writing a bare equation, we used to add an error term.
Sir?
Sir, is my doubt clear, sir?
Yeah, yes, sir, I got it. I got it, sir.
Okay.
I got it. See, when you are making an estimation, the estimation, okay? Hello?
Yeah, you are clear, sir. I can hear you, sir.
Okay, sir, fine. See, this when I am trying to make an estimation, so I want to get what is the estimated value, that is the regression value.
Yeah.
Okay, so the regressed value is my estimation. The actual value is another this thing.
Yeah.
Okay, the difference between these two, the difference between the actual, the difference between the actual and the estimation is what we call as the error. Therefore, we are using, I think earlier I have explained this one.
Yeah.
So when you make an estimation, we want to get the exact value. So if I put an error term to that, the error term, when I add an error term into that, I cannot quantify it, no?
Yeah.
Therefore, it stops there because then only we can do the estimation.
Okay. Need not put epsilon, no? We need not to. Okay, sir. Now it is clear.
A couple of slides ago, to write the actual is equal to, actual y is equal to estimated y, that is ye plus e plus ei, the error.
Yeah.
Okay, sir. Are we resuming?
Okay, sir. Okay, sir.
Right. Okay. So this the slide that right now you are seeing, this also another kind of exercise on that. That is regarding a certain. I just tell you what is this about. No, we are not going to the statistics part. A researcher collected data to predict the annual growth per acre of upland teak wood in southern India. The cubic foot volume growth, that is Y, the dependent variable of teak wood, is taken as a function of stand basal area per acre, x1, the percent of that basal area of other trees in the farm, x2, and the stands site index for any tree. I just to tell the situation. So you are growing, you want to grow in a particular upland area, hill area, perhaps, teak wood. So how much you would get your cubic meters or cubic foot volume is what is required here. So what are the independent variables? The area under basal area per acre of teak wood. This means, I mean, this is the peculiar measure this one is. So up to a normal person's height, say 6 foot. At 6 foot level, in an acre of land, you might have grown planted several trees like that. So what is the girth of each tree, teak wood? This one they are computing, they are adding. So that is that measure. Similarly, there might be other trees as well. For that also, what is the girth level that is at sufficient height of, say, at 6 foot or something like that. Then the site index refers to for tree cultivation per se as such, whether the this thing is fine, that the area is fertile, does it give good yield, something like that. So this is what the kind of thing. Everything is measured. So this is how the equation comes. There's similar. I mean, you go to the next slide. Next slide. So you may get a result like this. You must be able to interpret this result. That's all. How to interpret this result? The cubic, I have put this meter here. It must be foot. Take foot. Basal area. This is 0.816. It's very high, and it is also significant. It is also significant. The significance level is placed just beneath the B. These are all B1, B2, B3 only. These are all. The next basal area for other trees, it is also having a positive impact, but low. This is also at the P value is 0.029. That means around 3%. If you take 5% of the significance level, this is also highly significant. Whereas the subsequent column, the next column, you have minus 0.14. This is very low. And this is not significant as well, because the significance value is more than usually taken the 5% level or 10% level or 1% level. This is 0.466, means 46 or 47%, therefore not significant. The site index is also having pretty good influence on the amount of teak wood, cubic meter or cubic feet of teak wood that you are going to get. At the bottom, you have your multiple correlation. R equal to so much, R square is equal to so much, and the R square is generally expressed in terms of percentage. Okay. Then adjusted R square is equal to 94.97%. 94.94. Usually there used to be one adjusted R square. For that only I'm coming here. So what is this adjusted R square? The adjusted R square. Another next chart you take. R square is equal to TSS minus RSS divided by TSS. That is total sum of squares minus residual sum of squares divided by total sum of squares. What is total sum of squares? Actual y value minus mean y value squared. Each item you have to square, each pair you have to square, and then you have to add. Therefore, sum of y minus y bar whole square. RSS is equal to, that is residual sum of square, there is a error term, is y minus y e expected, estimated. So it actually means from TSS total sum of squares, if you subtract residual sum of squares, the error term, what you get is the explained variation. That is, how much of the total output is explained by the independent variation. So explained variation divided by total variation. So this is how the equation goes. Now the point I wanted to tell is what is this adjusted R square? So adjusted R square, a modified version of R square. What adjustment is done here? The adjustment, why adjustment is required? It is adjusted for the number of predictors in the model. The adjusted R square increases when the new term improves the model more than would be expected by chance. It decreases when a predictor improves the model by less than the expected chance. That is, an item is added, an independent variable is added, thinking that adding one more unit will lead to more precise estimation. Okay, you are good. But sometimes the inclusion of an additional variable might have improved our prediction, but that could have been due to chance also. Not because it's a causative factors, but due to chance factors. So if it is more than the chance factor effect, then it has a positive influence. Otherwise, less. This is what is captured by the formula placed under adjusted R square is equal to 1 minus of 1 minus R square, that is the calculated R square into n minus 1 divided by n minus k minus 1, where n represents the number of data points in our data set, k represents the number of independent variables. So this is how it is done. I hope, because we must know the idea behind adjusted R square, that's the point. And this table, next table I'm skipping because we have to cover a few more things as well. I'll go to the next one. Scholars, research scholars, research students must be able to extract the regression equation. From the regression table, we must be able to extract the equation. So for that, what you have to do, go back to the previous table. Yes. The previous table, the second column gives all the thing that we require. So the coefficients column gives all the b values. The first one constant, we may take in even we may take it as b naught, or we may take it as a. Normally in multiple regression, people prefer to use b naught. The next one b1, next one b2, like that. Therefore, that minus 19.358. Next slide now, plus the coefficient written over there of the basal area under teak wood, plus coefficient for the basal area for other trees, plus coefficient for the site index, like that. This is how the equation is done. This is a small thing, but still we should not have any doubt over that. Therefore, I put it. Go to the next one. I think the next one I can skip because a similar exercise. So go to the other one. Yeah, have this. In this slide, you find at the end one VIF. What is this VIF? This is called variance influencing factor. This is called variance. Go to the next slide. Go to the next slide. Variance influence or inflation factor. Variance inflation factor. These variance inflation factors range from 1 upwards. So 1 upwards means not less than 1. So the numerical value of VIF tells you in decimal form what percentage of the variance, that is the standard error squared, is inflated for each coefficient. So this is what it tells. Again, go back to the previous table. Go back to the previous table. So regarding this particular one, on the rainfall, agricultural credit, etc., used here as independent variables, the rainfall is having 1.148 as the variance inflation factor. Institutional agriculture credit has 17.3932 as the variance in inflation factor, like that. Therefore, when go to the next slide. Usually, when the variance inflation factor is between 1 and 5 is okay for us. If it is more than 5, it's not good. Why it is not good? There is multicollinearity. So it is not good. When the variance influencing factor more than 10 is included, so there is a concern about that. So therefore, when the final result gives variance inflation factor of exceeding 5, we have to be careful, especially when we do research for action purposes, decision purposes, that is by companies, we have to be very careful. For academic research, also we have to be very careful because we have included factors that are called independent factors which are having multicollinearity among themselves. So this is happening. Therefore, we have to be cautious of that. Okay. Then we are going to the next one. Yes, canonical correlation. What is this canonical correlation? Correlation we know. What is canonical correlation? This canonical correlation is a correlation where on either side, when we usually have done correlation with multiple correlation, simple correlation we know. 2 factors only, X and Y. Multiple correlation, X on one side, ABC on the other side, or YZ on the other side. Okay. What about having a correlation where on either side you have bunch of factors? A bunch of factors on either side you have. That is X1, X2, X3, and Y1, Y2, Y3, Y4. And we want to study the influence of Xi's, the correlation between Xi's, that is X1, X2, X3, and Yi's, that is Y1, Y2, Y3, Y4. This side 3 variables, that side 4 variables. In such cases, we have to go for what is called as canonical correlation. How such a correlation is done? Only that point I am going to tell, not more than that, because again, we must understand what it is. Then the rest is a black box concept, because we cannot humanly work out problems. Only systems do. Therefore, with a package, we do that. We solve that. So there is one canonical variable or variate we have to compute. Canonical correlation involves the linear combinations of sets of original variables. These variables are a form of latent variable. This is the point I want to dwell. And there are 3 variables on the X side on one side and 4 variables of Y category on the other side. To do correlation, it would be nice if we have only one on either side. In that case, what we can do, the 3 variables of X can be converted into a linear combination of those X1, X2, X3, which represent all the 3 comfortably. How this can be done? Instead of X1, X2, X3, I want only one X. Instead of Y1, Y2, Y3, Y4, I just want an Y only. So how do we define this variate or canonical variable X for all the 3 X1, X2, X3, I want one factor X. And the X is given by B1 X1 plus B2x2 plus B3x3. So x1, x2, x3, we had several things. I am attaching one B1 to x1, B2 to x3, x2, B3 to x3, and x1, x2, x3 are having individual values. If I put all these things, I will get a numerical value. Therefore, the 3 are reduced to one number. The other side, I have y1, y2, y3, y4. I may go for 1, or I can even go for 2. y1 and y2, y3 and y4 together. So this is how linear combination of set of original variables. The original variables are converted into linear combination. What is linear combination? A weight is attached. Power is kept as only any power, not a square or cube. That kind of thing is not happening. Therefore, only linear. So this is how this combination is done. So what should be the basis for these linear combinations? The basis of the linear combination. Here, correlation coefficients, simple correlation coefficients again comes into play here. And how this is done, we are going for a factor analysis quickly. In factor analysis, this is done. There I will explain. Then, so this another concept you must be, I mean, this is eigenvalues are a kind of linear, algebra related. My dear participants, we must know good amount of algebra, good amount of geometry. Then only we can enjoy all these things. So I think many of you would have studied business mathematics. Under business mathematics, you would have studied set theory. There you would have come across this kind of feature, that is variable, eigenvalues, eigenfactor, eigenvector. Okay. Again, these are all correlation related only. With this, I stop. I'm not getting in further this into that. So we must know these things. Okay. I'm going to next slide. Cluster. Go to the next slide. Okay, next one. Yeah. So multivariate analysis continues. Cluster analysis, conjoint analysis, discriminant analysis, factor analysis. So a couple of things we will be able to see. Okay, let's see. Go to the next one. So the cluster analysis. So cluster analysis, so I just tell you there are n number of entities, a wide group, a large group. The large group might consist of many subgroups. We call each group here as cluster, that's all. So cluster analysis. So what we do, there can be two kinds of clustering. One based on mean distance between two things. There are n number of things. The n number can be put into, say, taking 2, 2, 2 each time, n by 2 groups. That is the half that number. Then the half that number, which two will be taken first? Perhaps any two entities whose mean score is almost same. They constitute one. For example, take the case of a classroom. Thousands of students have passed out, and their score is 65 to say 85. So I can make a group of all the people who are having a mean score of 65 and all students having a mean score of 67, 65 and 67. So I have reduced the group, and the mean score may be 66, need not necessarily be 66, maybe 66. Then another case, 68 to 70, I may convert into one group. Then later what I can do, these two newly formed groups can be converted or can be joined to make another group. So this is called something called as a hierarchical grouping, clustering. So this is one of the methods. All this is needed to just know, are there any subgroups within the total, so that each subgroup may have certain special features. We may have to concentrate on certain groups, certain clusters, which are having certain features, so that it can be further groomed, or we can do some experiment with that, or we can target that group for marketing our product, something like that. Another one kind of clustering is called on a two-dimensional scale, x-axis, y-axis. You do some scattering of this data and try to make groups. Some group may be at the lower end of both x value as well as y value. Another one may be at the extreme end of x, but at the bottom of y, therefore moving horizontally a longer distance. One group may be at the middle, another group may be at the both end of the highest point, that is x highest, y highest, therefore the extreme right top corner. So these are all cluster analysis. So all these things may help in taking some decisions. So I am passing. Go to next slide. Next slide. This one. So these are used for business choice. That is, which cluster I should concentrate with my marketing. So whether this cluster I can go with or some other cluster. So take the case of Indian market. And in Indian market, if you see that there are foreign car companies as well as Indian car companies. Maybe the Indian car companies, perhaps take the case of even Maruti, it's concentrating more on the price conscious segment, perhaps. It's there. People say that similarly featured vehicles for certain special components, features they are having. The price of the foreign brands used to be 5-6 lakhs more, not less than 20 lakhs at all. Whereas a similarly made similar features, at least physical features, if not internal, Maruti is able to offer at something like 5 or 6 lakhs rupees less. So therefore, the business choice of these two kinds of companies, that is one, those with a foreign brand and the one with a totally an Indian brand, they may differ in their business decisions like this. Then behavioral studies, clinical studies, climatic studies. So in all these cases, clusters can be done. So pass. Other slides I'm not going into. Next slide. Next slide. Next slide. Yeah, this is the hierarchical kind of thing, T diagram. Okay, ultimately you see finally one group comes. Only one group finally emerges. Next. 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 This is one. So this is called again grouping. We have been doing with one particular exercise throughout, that is a wide area network. So non-hierarchical K means number of samples, number of populations. That procedure is followed. 200 respondents. Those 200 respondents have been classified by the system, that is the program, cluster 1, cluster 2, cluster 3. The cluster 1, number of people 62, cluster 2, 55, cluster N, 83. How these clusters are made out? The range, mobility, sound, place, receive, send, average billing, telephone models, installation efforts. All these things I hope you can understand, because this is a continuation of this multiple regression analysis which took the first case. Couple of more variables only added. Here all these numbers refer to, for example, range. If we take range 6.8, you find one for the cluster 1, 8.1 for cluster 2, 8.2 is the cluster 3. What these are all, I have to tell you, this is based on the importance rating for range. Importance rating for range. And the ratings are 1 to 11. So the cluster 1 people, the 62 people, for their importance rating 1 to 11, the 62 people might have given, one person might have given 5, another 8, another 6, another 11, another 2, like that. So the average comes to 6.8. Another group, second group, 8.1. So for this second group, 55 people, for the range it comes to 8.1. That is the mean score for the 55 people. For range factor, rated on a scale of 1 to 11. Similarly for the cluster 3, 83 people, 8.2. Rest of things I need not explain. So this is how the values are worked out. Now take the cluster 3. The cluster 3 people, all the mean scores for the variables are very high, 8.2, 8.2, 8.5, 8.7, 8.6, like that. Come to the middle group, middle cluster, it is 8.1, 8.1, 8.5, 8.3, 8.5. The last two, 6.3, 5.1. Therefore, the last two telephone models and installation efforts, here this cluster is significantly different from cluster 3. And cluster 1, on 3 factors, namely sound, average bill, and telephone model, the average score is 8 above 8, 8.1, 8.6, again 8.1. The rest of things, they are different. So this is how this cluster is made. So everything is programmed because it's the voluminous data of 200 persons, 1 to 11 scaling, and 1, 2, 3, 4, 5, 6, 7, 8 variables. This is how it goes. So this is what the system does it. And it gives clusters like this. Now it is for the company, that is the company which wants to go with the wide area network service provision. It may concentrate on cluster 3 with the 83 people out of 200. This is the largest group also. Out of 200, this is the largest group. That is a 41.5%. Therefore, the company may decide, okay, we will cater to the needs of these people. That is, they expect pretty good things. And they are also willing to pay, among the 3 clusters, they are interested in paying more, 8.8, like that. So this is how this kind of analysis is done. And go to the next slide, please. This is a multiple discriminant analysis. Multiple discriminant analysis. So we have seen multiple regression analysis. Now it is multiple discriminant analysis. In multiple discriminant analysis, you see the actually you can see the equation given. The equation is Z is equal to B1x1 plus B2x2 dot 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 Bnxn. Please note that here the dependent variable is non-metric. The dependent variable is non-metric. Non-metric means it is not having zeros, unique zero, nor uniform graduation in the scale. So this is nominal. I will explain, we will understand. See, the dependent variable is cell phone owners and non-owners. The cell phone owners and non-owners. Independent variables are this range, mobility, sound, place, all these things. Here the respondents are classified as cell phone owners with code 1, cell phone non-owners with code 2. You may ask me, sir, for the non-owners, why not you give 0? They are not owners. For owners, you give 1. For non-owners, you could have given 0. The point is, it makes no difference. We are just interested in finding how many 1s and how many 2s. How many 2s only we take? 10 2s? That's all. 10 into 220, that we are not going. Okay. Therefore, this is just for identification. Therefore, this is non-metric. Okay. Then, another this thing you must also note. In the multiple regression, we started with the B0. We initially started with the A plus BX. Then I introduced the B0 plus B1x1, B2x2, like that. Here, there is no kind of thing as A or B0. Why it is? This is the case with non-nominal kind of things. Because it has no unique origin point. So therefore, it simply starts with there is no y-intercept. There is no y-intercept in this case. Therefore, that intercept factor, constant factor is not there, because the people will be either classified as having or not having, and another class, there is no other class possible. Okay. Next. Previous. The last line, please read. Z equal to minus 0.02x1 plus 0.22x2 minus 0.36x3. This is given by this system, the package. So that we have taken, that's all. Based on that, workings are done. Workings are, go to the next slide. So what is this one? It's a funny problem, funny situation. See, there are 200 people in a sample. 200 people in the sample. The table, if I'll explain, you will understand. There are 200 people in the sample. Out of the 200 people, 126 people so I come this way. Out of the 200 people, some people are having cell phone. Some are not having. Some people are having cell phones, some are not having. Now we have found out that out of 200 people, 126 are having cell phone. That means 74 people out of 200 do not have cell phone. Okay, let it be. What is the thing you want to tell, sir? Please tell. You are asking me. I am answering that now. Now, the discriminant analysis is thinking of a scale to define these are all the people who would be possessing a cell phone. These are all the people who would not be having a cell phone. How the method is trying to get an answer for that? This is based on the previous table, previous table. So these are all the preference scores for the people. Go to the next one. Next one. Oh, sorry, previous. Again, previous. Yeah, here is. Oh, next. Yeah, stop. This one. So, see this here. They have devised an equation z equal to minus 0.02x1 plus 0.22x2, all these things. The x1, x2, x3, x4, these are all the values that each individual, that is the 200%, would give for each one by each, would be varying. Whatever values that, say, person 1, 001, what he has given for x1, what he has given for x2, what he has given for x3, what he has given for x4 and xy, you put it. And you get an Z score. Similarly, for all the 200, you get an Z score. So 200 Z scores are available. Based on the 200 Z scores, the multiple discriminant analytical and that software package, as it is programmed, tells these are the people with cell phone. These are the people not with the cell phone. Actually, who are having cell phone, we know. Actually, who do not have cell phone, we know. But based on the method, the system, this computation multiple discriminant analysis is giving a list. These are the people who are having cell phone. Actually, some may not be having cell phone, but it says they have cell phone. And it says these are the people, that is 200 minus that number. These are the people do not have a cell phone, it tells. But actually, some of these people might have cell phone, but this discriminant analysis says they do not have cell phone. So now go to the next slide, you will understand. So, previous. Yes. So now I am reading the title, Multiple Discriminant Analysis. Then the table part, detail, percent correct, group 1, group 2, total. Again, first row I am reading, G, that is group 1.0, 73.8, 93, R means right, 33, that means wrong. Now I tell you, the last column you have 126. This is the actual number of people who are having cell phones. But the system based on the model Z equal to this is plus and the score, and it gives these are the people who are having cell phone. These people do not have cell phone, it tells. Let us see how it has happened. Out of 126 people who are really having cell phone, this model, the discriminant analysis says 93 people are having cell phone, 33 people are not having cell phone. Got it? Then that means out of 123 people who are really having cell phone, 93 people are declared as having cell phone by this model, but 33 people are declared as not having this cell phone. Then, out of 74 people who do not have cell phone, this model says 21 people are having cell phone, which is wrong. 53 people are not having cell phone, and the model correctly says the people are not having cell phone. So now we are coming to a point. Out of 126 people who are having cell phone, 93 people are declared to have cell phone by the model. Good. Out of 74 people who are not having cell phone, the model says 53 people are not having cell phones. Correct. Therefore, if you add these two, the correct decisions, 93 plus 53, 146. So out of 200 people, for 146 people, this model correctly gives the solution. That is, out of 200, for 146 people, 93 people have cell phone, and the model also says they have cell phone. 53 people do not have cell phone. The model says, yes, they do not have cell phone. So this is correctness. So this comes to 73%. You can see it in the last row. In the percent correct, 73 you find. This is how the 73 was got. And above you find 173.8 to 71.6. What these are all? These are all obtained. The last column, first row 126 we have. Here the right decision is 93. So 93 divided by 126, if you put, it will be 73.8%. The next row, second row, data row, 74 people not having cell phone, 53 are correctly identified. So 73 divided by 74, the percentage 71.6. Okay, the percent correct column you cannot add. Whereas the other columns, other rows you can add, the total will be coming on the edge. So now the point is, the discriminant analysis method that we have designed is giving a solution of 73% correct answer. 73% correct answer. That is, those who are having cell phone, it says yes, they have. Those who are not having, it says yes, they are not having. But some are left out. Anyway, 73% decision is okay. Now, is this can we depend on this model? That's a question arises here. For this, what you have to do, see, in the case of group 1.0, the percent correct is, there is one P naught, no, 0.63. 0.63. And the next column, 0.37. What these are all? Out of 200 people, that 126, these are the people who are having cell phone, so 0.63. So the actual ratio is 0.63 out of 200. Whereas the model is able to predict 73% correct. When the model, so now what they are calculating is criterion, proportional criterion they are calculating, which is given by p square plus 1 minus p whole square. This is how they are doing it. So the p is equal to proportion group 126 divided by 0.63. 1 minus p is equal to proportion in group 2, that is 74, there by 200.37. So the C proof, that is equal to p square plus 1 minus p whole square. simply 0.63 square plus 0.37 square, total comes to 0.53. Now, the model says with the percentage of population having cell phone 63, not having cell phone 37%. Any model, if it gives prediction ratio of 0.53 is okay. How 0.53 is obtained? P square plus 1 minus p square. That is 0.63 square plus 0.37 square. This is the model. Whereas this discriminant analysis has predicted 73% of the cases correctly. That means it is more than the required one. It is enough if 53% or 0.53 proportion is done finely. Here it is doing 73% finely. Therefore, this discriminant analysis method is able to discriminate between who are having a particular thing, who are not having a particular thing. Here we have taken cell phone. It can be any kind of thing. So this is discriminant analysis. Go to next slide. This is some fundamentals. Just leave it. Just leave it. Next. 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 This is a factor analysis. I want to tell something. So now, with an example, we'll take. Go to the next one. Next one. Next. 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 Yeah, we start here. See, we are thinking of factor analysis here. On the slide you find there are 5 users of automobiles. They are giving ratings. The ratings on a 1 to 5 scale, that is interval scale. On end gives a 5 out of 5 for smooth ride for a particular car that he is using, or any car, and then the quiet ride he gives 4. Acceleration, that is a speed, within 10 seconds you can reach 60 kilometer speed or something like that. So that is the acceleration. But he is not considering this as a very important one. Therefore, acceleration is not important for him. Therefore, he just gives 2. I think the maximum is 5, minimum is 1. And the handling easiness, for that also he is not giving that much importance for that. So it doesn't mind even if handling is somewhat difficult, some rough. Whereas he gives maximum importance for the smooth ride and quiet ride. Quiet ride means very pleasant. Okay. Next person, Babu. He gives a weightage of 4, 3, 2, 1, respectively for smooth ride, quiet ride. Okay. Kathy, she gives like that. Dana gives score 5, 5, 2, 2. Einstein 4, 3, 2, 1. Florence like that. The average score we have got it. Now talk about the factor analysis. Here we talk about variables. These are all variables. But factor analysis we are considering here. What is that factor is about here? The factor point is from out of these variables or attributes, certain attributes are combined to make one factor. The rest of attributes are combined to make another factor. That is how the factor analysis. That means here, if smooth ride and quiet ride can be combined to make one factor, and acceleration and handling ease combined to make another factor, this 4 attributes can be reduced to two factors. With two factors, we can do all our analysis, and the analysis will be even better, greater, and you can reduce. Here only we have only 4 variables. Suppose there are 14 variables, 14 attributes. You want to analyze everything. And in that case, data reduction is required. Without losing data quality, without reducing data quality, data reduction is possible. And the data reduction is done by factor analysis. And how this is being done? This is the kind of exercise we are doing. Go to the next slide. So here in this slide, what is done is, go back to previous slide. You know, the first two attributes, that is smooth ride and quiet ride, are taken to mean either prestige or luxury. Smooth ride, quiet ride. Quiet ride, no sound is seen, heard. Smooth ride, even jerks, it just takes so lightly. So these two attributes can be combined to make one factor, and the factor may be called as luxury or prestige. Okay. Similarly, the other two attributes, acceleration and handling, may be combined and may be called by another name, that is a factor name. Maybe this is performance. Okay, so this is what is attempted subsequently. Yes, next column, next row. Yes. So what is done here, Anand's score for that first one and the second one, that is smooth ride and quiet ride, we average and put it here, 4.5. Similarly, Anand's score for the last two attributes, that is acceleration and handling, we add and get the average. Similarly, we have done for each. Okay. Now the average of average is also done at the bottom. Okay. Now what is required is, from out of these 4 attributes, we are going for 2 factors. How these factors are named by us as luxury, the other one performance. We can have it. Go to next slide. Now these factors are present at the bottom of this slide. Factor 1, we name it, I mean for understanding purpose, we name it as luxury or prestige. That is equal to the combination of all the 4 attributes. Please note that we are not leaving any attributes, but all the things will be there. How much? 0.96x1 plus 0.99x2 plus 0.08x3 plus 0.48x4. The F2, that is factor 2, we call it as a performance. Okay, that is 0.18x1, 0.38x2 plus 0.92x3 plus 0.93x4. These 2 equations only we have to concentrate now. First of all, how I got this 0.96, 0.99, that is the coefficients. You may call it as B1, B2, B3, B4. Another one again, 0.18, 0.38. How do we got it? It's very simple. Please note, carefully note. For factor 1, take x1, 5445 take that luxury mean square 4.5, 3.5, 3.55, 3.55. Okay. Get the correlation between x1 column variable and the luxury mean square MS. That correlation comes to 0.96. That is where the 0.96 x1 is coming. For x2, 4, 3, 3, 5, 3, 5, and again that luxury mean score 4.5, 3.5, 3.55, 3.5, get the correlation coefficient. This is 0.99 x2. Similarly, for x3 with the luxury mean correlation coefficient, x4 with luxury mean square correlation coefficient 0.48. Now I have got F1, the factor 1. We may call it as luxury or prestige. It has all the 4 attributes, but first 2 attributes are having huge weight, whereas the third one very, very small weightage. You know, correlation can take value between -1 to +1 only. Therefore, 0.96 means almost the maximum. 0.99 means almost 1 maximum, whereas 0.08 is very, very low. 0.48, the last one for F1, fairly good, 50% positive side is there. So this is, similarly, we have worked out the correlation coefficients taking x1 with the performance mean square, the last column 1.5. Again, x2 with the performance mean square, x3 with performance mean square, x4, this thing. The correlation coefficients you can find even at the bottom of the blue letters, purple letters you find correlation coefficient 0.18, 0.38, 0.92, 0.93. This is what I am taking behind. So the F2 being the second factor, 0.18 x1 plus 0.38 x2 plus 0.92 x3 plus 0.93 x4. Okay, this is that. Here we find that factor 2 is giving maximum weightage for the performance variables, namely acceleration and handling, with correlation coefficients of the range of 0.92 and 0.93. Whereas the first 2 factors, it gives less, and the first one it gives the least. This is how it goes. So this is the most fundamental aspect of factor analysis. So from the variables, factors are produced like this. Then it does all the analysis. So go to the next slide. Then it goes to the next slide. So the above one, I mean previous slide, previous. Let this slide continue. Earlier, we saw a slide with x1, x2, x3, x4, and also luxury mean square and performance mean square. The first 2 variables, attributes x1 and x2 combined to make F1, but in that F1, x3, x4 will also be there. Please note that we are not ignoring that. The second 2, the third and fourth attributes, we call it as performance factors, F2. And here also we take x1 and x2, but with the lesser weightage. We are not giving this lesser weightage. This is what this we obtain from the scores given by the respondents. Nothing we have done. So in both the F1 and F2, all the 4 variables are there. This is what you have to keep in mind. Though F1 is having more loading, factor loading. This is the word they will be using. More factor loading with respect to attribute x1 and attribute x2. And whereas F2, the factor 2 is having more factor loading with the attribute x3 and attribute x4, while attribute x1 and x2 have lesser weightage. And go to the next slide now. Now, again, that particular problem we started with, that is wide area network. So factor 1, factor 2, factor 3. Here, see this, such a couple of factors are there. The variables we have seen, many variables, some 8 and all that. So out of that, they are making like this. See that range, mobility, sound, place, receive and send, average bill, telephone models, and installation efforts. These are the 6 variables. Out of these 6 variables, this method, factor loading, PCA, principal component analysis, Variance method. So he is giving correlation coefficients above. That is, with the factor 1, range is having a correlation coefficient of 0.7, whereas with respect to cost, it is minus correlation. Correlation is minus. With respect to factor 3, that is named as sound quality. Please note, range, mobility, sound, place, receive, send, average bill, telephone models. So out of these 8 variables, combinations are made, and under factor 1, certain variables only taken, maybe 2 or 3, and these are called in touch. In touch means, yes, why should I have a cell phone? I must be able to in touch with the people with whom I want to be in contact. Therefore, this facilitates in touch, range, mobility, place, receive or send, maybe like that. All the 4 may constitute this factor 1. And factor 2 is exclusively cost only. Therefore, this average bill. Factor 3, sound quality. There is one variable sound. There may be other factors also. For example, the range is also some influence on sound quality. Okay, when you are closer to tower, you have good quality. Away from that, you experience bad quality. So therefore, the model works out the correlation coefficients. See this. Here, hundreds of people you would have surveyed. All those hundreds of people would have given for each of these range, mobility, etc., different importance points. From out of those importance points, you would have got the mean. Then you are also thinking of factor 1 consists of certain variables, factor 2 consisting of 1 or 2 variables, factor 3 again 1 or 2 variables. For those combinations of variables put into different factors, factor 1, factor 2, factor 3, again for each person you have to get the score and the average score. Then, as we have done earlier, the correlation coefficient, here you have to do the correlation coefficient. All these correlation coefficients are placed here. So in this slide, from range to installation efforts, all the rows and the respective cells in the 3 columns are all correlation coefficients. You note that correlation coefficient can take negative values also. A couple of things we find a negative correlation, minus 0.12 for place with the factor 3. And for factor 1, average bill and telephone models have a meager negative correlation like that. Then this does not stop here. They do this exercise further, and whether these classifications explain the variation among the people in preferring wide area network service. Yes, the factor 1 is able to explain the variation is 2.75. Factor 2 is able to explain 1.81. Factor 3 is able to explain 1.18. So proportion to total. So this is how this analysis is done. And see, in all this multivariate analysis, nothing is visible, only results come. So we must know thoroughly what are the concepts, how these concepts have been defined, how the concepts are converted into measures, metrics like this, then how decisions are derived, how interpretations are made. So for that, a good amount of learning, deep learning is required. So in 3 hours time, I think we cannot cover much of these things. Go to next slide, please. So about these models I'm telling, and I'm not reading this out. Next. Finally, go to last one. Fast. Next. These are all connected with the factor analysis. There is one conjoint analysis. This is what. Okay. Next. Yeah, I have this previous one. See, you are a golf player. You have to go for the golf balls. You have to pay a price. How much you can afford to pay? How much you want to pay? On what basis this is decided? So the price of the ball, average ball life, average driving distance, these are all certain matters that as a player you will be interested. Therefore, these factors you get into our analysis, and how this is done. This is what we are doing. Next. Say this. This is a conjoint analysis. User 1, user 2. User 1, if the ball with a one kick, it covers very easily 275 yards. You'll be happy very much. Next level, 250 yards. Okay, not very sad, but okay. Whereas 225 yards only, these are the least. Whereas then another metric that is coming into the analysis of 54 holes and 36 holes and 18 holes. Okay. The preference for, okay, go to the next one also. Oh, fine. So here what is done is, for everything, a standard score is given as important. For example, 275 yards, okay, you take 100 points for that, good. 250 yards, 60 points, 225, 0 only. 54 holes, 50, 36 are 25, and 18 holes is 0 only. Now what? Now the user one will be ranking the balls like this. What? He gives maximum score of 1 in the first cell. Why? This 275 yards, 100 points, plus 54 holes, 50 points. So 150 is the maximum he is having here. Whereas if he moves to the 36 holes, 100 plus 25, so 125, therefore that takes second place. Whereas the next one goes with the fourth point, because there is one third point available with the second row and first column, that is 250 yards, 60, plus 54 holes, 50, therefore 110, therefore that is more than 100, therefore that takes place 3, whereas the other one gets 4. This is how finally the 9 is given for 18 holes and 225 yards. 0 plus 0, 0. Okay. Then in this context, the price factor is also now brought into situation. So I want the good performing ball with the least price. Therefore, $1.25 least price is best for me. Therefore, 20 points. $1.5, 5 points. $1.7 more price, least satisfaction, therefore zero satisfaction. Here also he makes the combinations and gives the ranking. So this is how the ranking is done. Conjoint analysis. So 2-3 things combined and a ranking is done. On that basis, decisions taken. Okay. With this, go to the next slide. Is that the last slide? Okay. Good teachers are the reason why ordinary students dream to do extraordinary things. Happy Teachers Day. I have one English issue to be dealt here. I have taken these images from websites. Teachers Day, here after teachers, there is an apostrophe. Another one I took, the apostrophe is a singular apostrophe, that is after or before yes. Whether these are correct? Or should be no apostrophe at all, Teachers Day. I think it's Teachers Day. Asiriyargal Dinam. Asiriyargaladu. Asiriyargaladu means you are taking more possessiveness of your profession. It's not celebration by you or you. It is celebration by others, by us also, for us. Therefore, it should be Teachers' Day, that is without any apostrophe issue here. Okay, next slide. We have to be very, very ethical in our work. Before you pray, we have to believe. Before you speak, we have to listen. Before we spend, we have to earn. We have to earn our knowledge. Thank you.
Thank you, sir.
The participants who are willing to interact with the professor, you are wholeheartedly welcome for interaction. Any clarification? More than 100 participants are there.
Oh, great.
Good afternoon, sir.
Please introduce yourself, then you
Yes,
Sir, good afternoon,
my
sir.
name is,
Please.
yes, sir. My name is Asim Mustafa, scholar from Department of Education, pursuing my research from Aligarh Muslim University.
Great.
Yes, sir. I have a question, sir.
Yeah, please.
As you have explained very well the factor analysis techniques used in social science research. Sir, I have a question. I am constructing a tool. Is it necessary to use factor analysis while constructing a tool, or we can use the Cronbach alpha or other statistic while using or constructing or standardizing a tool?
See, Cronbach alpha you are referring, okay?
Yes, sir.
And factor analysis, these two things you have referred. Okay. Cronbach alpha is known for the normality of your data. We normally assume normality, whether the normality is taken care of, for that we go for Cronbach alpha. Whereas the factor analysis you go for, if you see when you in your enthusiasm, you might have gone for 15, 16, 20 different factors into analysis. I mean, variables into analysis. And it is quite possible you can get the very precise answer with a combination of these factors into these variables into certain number of minimum number of 3, 4, or 5 factors, and that makes analysis pretty good, because in a way this will reduce the multicollinearity. After data reduction, you will be going for all analysis. In that case, the multicollinearity will be totally eliminated. Whereas with the 14, 15, 16 variables per se, if you analyze, among them a lot of collinearity problem will be there. So that may not be helpful in interpreting the results, because everyone might be showing itself as very important, but actually even ignoring some of those things, we can get the same kind of preciseness. But we are not ignoring anything. Actually, we make them into linear combinations of factors, linear combination factors. That way, we are not removing anything, but we make them a little more compact, meaningful ones, focused ones.
Sir, actually, there are many standardized tools in NPC catalog and many other catalogs. There are various standardized tools, and the person who has constructed the tool, many of them didn't use the factor analysis as a technique for construction or standardization of tools. They, for showing the reliability, they use the Cronbach alpha and inter-item correlation, inter-consistency coefficient. And my question is this, sir: if necessary to use technique while constructing a tool in social science research, and what have already choose the dimension, because factor analysis is a technique in which the different items are interchangeable in different dimensions at last when we use it.
Okay, the factor analysis does not stop with getting the factors. It goes beyond. That means when we are interested in predicting, we need not go up to the 99% precision, spending a lot of effort.
Yes, sir.
It is enough we reach 90% precision with half of the efforts. Efforts may be money, maybe time, or maybe all such things. Therefore, you make a trade-off between efforts to achieve the maximum precision, a trade-off. Okay, I am sacrificing precision to the extent of 5% if I can save 2% efforts. The 2% effort saving is done through this kind of factor analysis, data reduction. So if you are not interested in this kind of analysis, you want 100% purity, then you may go ahead. But you can go ahead because prediction will not be a problem. They say that prediction it may make, but interpretation, because every person will say, I have gone to every variable will be given to understand that it has contributed much, it has contributed much, whereas there is no need. When one person can do, when a machine can do what 3 people can do your work, why should you go for 3%? You give it to a machine. So something like that, a combined factor which consists of 4 variables, it's capable of giving the result very perfectly, 98% perfect. You can accept that. So that's a kind of this thing. So we cannot say you should do, you should not do. So we leave to individuals this thing. Okay.
Nikita Shetty is on.
Okay, sir. Okay. Thank you, sir.
Nikita Shetty.
Yes, sir.
Yes, please.
Yes, sir, I am Nikshita from Mangalore University. Sir, I want to ask one question related to my study, sir. Actually, I want your comment about that. Actually, I was there in the submission stage of my thesis. Sir, my question is, sir, any rule is there whether null hypothesis should not be accepted? Like that, any rule is there, sir?
Null hypothesis is a hypothesis of no relation, no influence. That is null hypothesis. When
Yes,
you
sir.
enter into a study, the intention is perhaps you have thought that this particular variable has influenced another result. So therefore,
Yes, sir.
If you want in the case of a regression kind of thing, null hypothesis bi is equal to 0. Alternate hypothesis bi is not equal to 0. If null hypothesis accepted, we conclude that there is no relationship. When there is no relationship, why should you venture into studying to show that there is no relationship? Unless some people are telling that there is really no relationship, but somebody are claiming there is relationship. So if such is the motivation, we have to enter into this kind of study. Therefore, it all depends on what you want to show to this world. People are claiming to be these factors influence.
Yes.
But you know this is not at all influencing. Therefore, your null hypothesis, when it is accepted, that's good.
Okay, sir. Yes, sir.
Whereas
Actually,
if the world is the other way, they are saying there is no influence, but you are finding that there is influence. So your null hypothesis is rejected. So therefore, you stand to gain. Therefore, what is the general or public or popular opinion? Are you consuming that general popular opinion, or you want to take a opposite stand? So to take an opposite stand, you prove your case with statistics. In that case, it all depends on what is the situation. Accordingly, whether in certain cases rejection is maybe preferred, in certain cases acceptance may be the thing required. It all depends on the situation. Okay.
Vinit Kumar and Sinha.
Sir, excuse me, sir.
Introduce yourself.
Sir, excuse me, sir.
Hello.
Yeah, please. Yeah.
Sir, good afternoon, sir. It is very nice talk. It is very informative also. Let me congratulate. Happy Teachers Day, sir. My query is multiple regression analysis and multiple discriminative analysis and factor analysis. All these are meant for testing hypothesis or only only descriptive analysis. And what is the layman differences between among all these three? Please, sir.
So in all the cases, testing of hypothesis available. In all cases. So in the discriminant analysis situation, we also showed that whether the discriminant score is able to distinguish between the owners of cell phone and non-owners, we proved no. Therefore, this model is good. So therefore, if how this model will be useful means it's not for layman. From business perspective, these are all having certain points. So business perspective says that this particular model will help identifying markets which are interested in going for cell phone, which are not interested in going for cell phones. Therefore, applying this model, if we can find out, out of these 10 clusters or 10 markets, sample markets, these two are found to be really worthy of trying because the model is able to predict. So therefore, it helps in taking great decision, good decision. So we have to see from the business perspective. So in the social science also, what the society wants, what is societal good, that may be behind this study. So therefore, all these things are useful. And the regression, I mean, the testing of hypothesis, you know, up to undergraduate level, no testing hypothesis we insisted on earlier. Now we want this, whether the computed mean is really correct mean or the wrong mean. So we go for testing a hypothesis. Therefore, if you just stop with working and giving, it's okay. But is it really good one or otherwise? So you have to go for testing. So a benchmark you have to consider. Against that benchmark, you have to test and say, yes, it has passed the benchmark, so it is good. It has not passed the benchmark, so it is not good. So therefore, a useful knowledge is obtained. Thank you.
Thank you, sir. Sir, one more question. If we use more statistics, is it will enhance quality of our work, or with less statistics, can we enhance our research work?
Fine. That's nice. Good question. So, but it's not a more or less, but the point is whether it is a right tool used. So a right tool may be wrongly used. That part I didn't go. For example, you have a column of data, columns and rows of data. So if these are all measured data, what you should do, perhaps you can go for ANOVA, multiple regression. If these are all counted data, you can think of only chi-square analysis. So therefore, we cannot mix up these things. Therefore, not employing too many tools is one thing, but knowing too many tools is another thing. So researchers must know maximum number of tools available, statistical tools available, because for the present work, he or she may not be using all. In future, she or he may use all those things. Therefore, I want quality in quantity also. Everything depends on the kind of tool you have used, data collection tool. If data collection tool is wrongly constructed, I'm sorry that it may not give great results. So therefore, your questionnaire, your schedule must be well thought out and done.
Any other clarification, any other questions?
Sir, Binit here, sir.
Vinit Kumar.
Yes, sir.
Sir,
there is one question related to my research, where multivariate means multi items are there, and where one is independent are like price, agriculture, credit, marketing platform, cooperativism, and other side dependent are agriculture, fishery, etc. What kind of test like multiple regression or multivariate analysis are required? If it is so, either of these two are required, what will be the assumption?
Okay. Can you put your question in the chat box?
So it is a long question. It is a long question. I would say, sir.
That's why I could not take your question. So put your question.
Sir, taking multiple items. Multiple items like agriculture, fishery. Yes,
okay.
Sir. Multiple fishery, cotton, cottage industry are there. These are the independents. But the independent things are like price, agriculture, credit, marketing platform, direct marketing, cooperativism. These are the independents, sir. So taking row and column.
So you want to do 10 research works in one research work?
Yes, sir. Same thing my VC had told me.
How is that possible? So you should have 10 different things and put it in one book if you want. And each might require.
Is it possible?
I mean,
sir, thing is,
see, your variables must be related variables in some way or other. Totally unrelated things. I mean, in this world, everything is related to everything else. Is one argument is there. But here, what are seemingly related? So
it is a rural produce.
I got it. So rural produce, each product produces its own parameters, no independent variables impacting on that.
True, sir.
So
True.
if we cannot say that the conditions available for fishery will also work for say rice cultivation or paddy cultivation, things will be different. So such kind of study simply goes without any focus. People may say like that. Okay.
So if you see, sir, if you see the independent thing, it comes across commonly to all those items like price, agriculture, credit. If you leave marketing platform, direct marketing, or corporatism, these are the common independent variables for this kind of dependent. Is it possible, sir?
I mean, I'm not able to get your question still correctly. Therefore, put it and I will come later. Okay.
Okay, sir. Okay.
Put it in the chat box.
Okay, sir.
Good afternoon, sir. I am Dr. R. Iswaran from Kalasalingam University.
Nice, sir.
Happy Teachers' Day, sir.
Thank you. Thank you.
Today's sessions, univariate analysis, bivariate analysis, and multivariate analysis are simply explained. We are very useful sessions, sir. We got more information from your presentation, sir. Today, visually, we are meet great teachers. Thank you, sir.
Thank you. Thank you so much.
Thank you, sir. Thank you, sir.
Sir, good afternoon, sir.
Yeah,
hello.
Please. Yeah.
Sir, good afternoon. This is Dr. Jaiprakash from DG Vaishnav College, Chennai, Accounting and Finance Department. Okay. Happy Teachers' Day to all my dear faculty members and my gurus in this panel list. Sir, I want to know clarification regarding fact analysis. Why the fact analysis applied for most of the thesis? Is it necessary for fact analysis?
So I think you have already answered this question. That means, for example, when you have too many variables, normally we introduce too many variables generally because we want to extract very minute, very pertinent information. Therefore, we make our questionnaire elaborate, go for minute details, we get the data. So that's good. But coming to analysis, the thing is, one final goal is precision. Your measurement must be precision. Your classification by cluster analysis must be perfect. This you have to reach. To do that, instead of taking all the n factors, n variables as such, we can get result. But by a kind of data reduction, this only data reduction, no omission is there, that you have to include that. When 4 variables can be compressed into 1 factor, that's a good thing. So that is what is done. So, and that one thing is capable of explaining maximum variation in the regression. That's fine. So why should you go for out of n factors? Suppose some 20% of the factors or 30% of the factors are very insignificant contributors to the totality. Say 0.01%, 0.05%, 0.13%, like that. They are not making any sense out of that. Therefore, the real sense must prevail. For example, real sense of a meeting, how it is decided, okay, this issue is there, how many people are for it? Yes, 90% are raising their hands, matter ends. Therefore, that's the real sense. The 10%, whatever this thing, If you want to analyze why they are reluctant to, that's a different study. But to take the decision, what is the general mode? Okay, raise your hands. That's okay. So 51% of the people who are voting for, that's enough. That's how it goes. Therefore, it is up to you to use or not to use, but perfect analysis is required.
Yes, sir. Yes. Thank you so much, sir. Thank you.
Nice.
Thank you, sir. Thank you very much, sir.
Thank you.
Thank you. Thank you, sir. Dear participants, thank you for your valuable participation.
Thank you so much, sir.
Now the time for a vote of thanks. Dr. Parni Singh,
Thank you so much. Thank you so much.
I request you to deliver a vote of thanks, please.
So, very good afternoon to everyone. So, at the outset, I would like to thank the great founder, funder, and father of this university, the great Alagappa Chettiar. And second one, I'd like to thank the Department of Commerce, roped with the ICSR, conducting program. It's really enriched the knowledge of budding scholars, guides, and faculty members. And I would like to thank Dr. M. Selvam, sir, Vice Chancellor of Bharadas University. And sir has beautifully explained the nuts and bolts of the multivariate analysis, like bivariate analysis, multivariate analysis, univariate, nominal data, ordinal data, and interval scale and ratio scale. And in terms of foreign exchange, like, direct quote and indirect quote. So sir has, it's really amazing. And correlation analysis, regression analysis, and multiple regression, and canonical correlation, conjoint analysis. And in terms of data, whether we are using data is or data are, it's really amazing. It's really informative. And whenever sir taking the classes, like, 360 degree of knowledge, that is called Ongi, Aldu, Ongi, Nunniye. So that kind of information always instituting our mind to enrich our knowledge. And in terms of fact analysis, data reduction, data quality, and conjoint analysis. And sir has beautifully explained 360 degree of knowledge in terms of multivariate analysis. So it's really helpful. It's really enjoying the session. It's really flourished the knowledge in terms of all the dimensions of statistical analysis. And on behalf of the participant, I'd like to thank today's resource person, Dr. M. Selvam, sir, Bharadas University. And finally, I thank Department of Commerce. And on behalf of the participant, I wish you all and wish you a happy Teachers' Day, sir. Thank you, sir.
Thank you. Thanks. Thank you, sir.
Thank you.
Thank you very much.
Thank you, sir. Thank you very much. Thank you. A great day.
Nice. Fine, sir.
So, great day today. So, all the participants have become great.
Okay.
Thank you, sir.
Thank
Nice.
you, sir.
Happy Teachers' Day, sir. Everyone, happy Teachers' Day.
Yes, thank you. Thank you. Oh, this
Thank you,
is
sir.
fine. Evergreen
Thank you, sir.
in
I'm
the
from Sri Lanka.
Yeah. All the participants, be thankful to Professor. It will remain evergreen in your memory. Yeah, the PowerPoint serves as a treasure to you. It will help as a guiding light to you to pursue your research work and guide your research work. So anytime you can contact to Professor. He is a student. He is learning. He is studying. He is writing. So he will help at any time to you. You contact to him for further discussion. Thank you very much. A great day. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Sir,
Thank you. Nice. Okay.
for afternoon session, can we use the same link?
Yes, same link.
Okay, sir.
Same link for all the days.
Same link, sir. Same link. Please join, sir. Please. Thank you. Thank you.
Thank you, sir. Thank you, sir. Very nice session and a wonderful speech.
that way.